Okay, so we've got a question here. Y equals 5x squared plus 10x over x plus 1 squared. And we're looking to find the derivative of y with respect to x. So as y is this function here, we're going to take the derivative of this with respect to x. And such that we get the answer in the form of a over x plus 1 to the power of n. So we need to find a and n. So let's just write that on here. A and n. And they are going to be in the real numbers. Okay, so how do we do that? Well, as this is in the form of a fraction, one of the most common ways to find the derivative of that is to use the quotient rule. So, quotient rule. And what that states is that if you've got u over v, or du dv is equal to v times u prime minus u times v prime over v squared. Okay, so in this formula here, we need to assign what we're going to call v and what we're going to call u. So the numerator will be our u and the denominator will be our v. So let's just write these down here. So v equals x plus 1 squared, u equals 5x squared plus 10x. So now if you take the derivative of both of these, so therefore dv, so the derivative of this, so using the chain rule, bring the 2 to the front, keep the x plus 1 inside here, reduce this indice by 1, so that's 2 minus 1 is 1, so we can just put the 1 there, we don't really need it, and then multiply it by the derivative of the inside. Well, the derivative of x plus 1 is 1, so I'm just going to write times 1. We don't need these ones here, but they're there so we know what we did. And then du, so the derivative of this is just do each term at a time, so 5x squared, 2 times 5 is 10, and then reduce the power of the x by 1, so that's just 10x to the 1, and then the plus stays, and then 10 times x, so again we've got a 1 there, an imaginary 1, let's put it like that, 1 times 10 is 10, and then x to 1 minus 1 is 0, so x to the 0, well that is just 1, so therefore we don't need that term there. Okay, so let's just set out our du dv. So v times u prime, so v times u prime, that's this one and this one. So we've got x plus 1 squared times 10x plus 10 minus u and v prime, so that's these ones, so 5x squared plus 10x times 2x plus 1. Now let's just expand that out. Let's put 2x plus 2. That will take care of that. And then divide that by v squared, which is x plus 1 squared, all squared. Okay, now we need to tidy this up. So, denominator, that's going to be easy enough. X plus 1 squared squared. Let's put that one straight in. That's x plus 1 to the power of 4. Now here, let's go for this one. X plus 1 squared times 10x plus 10. So, x plus 1 squared will give us x squared plus 2x plus 1. And then we're going to multiply that by 10x plus 10. Okay, next one, this one here. Now we can FOIL this one out, we could also FOIL this one out as well. So let's take 5x squared plus 10x and multiply it by this, so 5x squared times 2x. So this is all going to be subtracted, of course. So 5x squared times 2x is 10x cubed. This one with this one. That will give us then 10x squared. The 10x with the 2x give us 20x squared. And the 10x with the 2 is going to give us 20x. Okay, now let's expand this one out. Let's do this one on the next line. So x squared with 10x, so that's going to give us 10x cubed. X squared with the 10, that's going to give us 10x squared. Now the 2x. 2x with the 10x, 20x squared. 2x with the plus 10, plus 20x. Okay, just left now with the 1, so we just need to write 10x plus 10 inside here. So plus 10x plus 10. Okay, now this is, we got this one here. Let's just put the denominator in, because that's not going to change. Now we've got to subtract these terms from this term here. So instead of writing it in, I'm just going to go straight in there and just subtract each one and cancel out if we can. So minus 10x cubed, we've got a plus 10x cubed here, so that is cancelled out. We've got a minus 10x squared, that'll be that one, so that will cancel that one out. So that's take care of those. We've also got a 20x squared, so 20x squared with this one, with the minus and the plus gives us a minus, so it means we can cancel that one out. And same again, minus 20x, and with this 20x, these will also cancel out. So after all that, we're now left with 10x plus 10 over x plus 1 to the 4. That's our derivative, but we want it in the form of a over x plus 1 to the power of n. So this is not an integer or a real number. So what we do know, we can see that as a 10 in here somewhere. If we do 10x plus 1, that will factor out this, gives us the same, we haven't changed the value or anything. And now we can just divide the top and bottom by x plus 1. So that will cancel out. One of those will cancel out. And then we're left with 10 over x plus 1, the power of 3. So therefore we can write in here our a equals 10 and our n equals 3. Okay, so that takes care of that. Now what we want to look for is where the domain of this derivative is. So what we're looking for is du dx larger than 0. So when is this going to be larger than 0? Well, we see we can't have minus 1, so x does not equal minus 1, otherwise we end up with 0 in the denominator. Now what about if we put minus 2 in there? So minus 2 plus minus 1 gives us a negative. Negative cubed is still negative, then our derivative is negative. So therefore, for this to be larger than 0, what we need is for x to be larger than minus 1. And all other terms beyond that will give us a positive in the denominator, thus giving us as a positive derivative. Now look at the next one, du dx less than 0. Obviously x does not equal minus 1. We've worked that one out. So now to be less than 0, we need a negative in here. So then we need a different answer for this one. So we just need the opposite. So x to be less than minus 1. So for example, if you plug in minus 3 plus 1 is minus 2. Minus 2 cubed is minus 8. 10 over minus 8 will give us minus 5 over 4. So then this is our domain for our function, and this is the values of this for our function. Okay.